after triangle law, we have another law called parallelogram. We know that how do we write parallelogram in short. So parallelogram law of vector addition. Alright, what is this law? In triangle law, we said if two vectors to be added, for example vector A and vector B, if two vectors to be added are taken as two consecutive sides of a triangle, then the third side would be the resultant of these two vectors taken in opposite order. Similarly, if now I'm stating the parallelogram law. If two vectors to be added, for example vector A and vector B, if two vectors to be added are taken as two adjacent sides of a parallelogram, then the resultant would be the third side of parallelogram. No third side, it's the diagonal. So I'll repeat again. If two vectors to be added are taken as two adjacent sides of a parallelogram, so the resultant would be the diagonal of the parallelogram, such that all these vectors are co-initial vectors or they have a common starting point. Let me see if I have made the diagram a bit horizontal. I think not, so I'll draw the diagram again and I'll repeat my sentence again. I am drawing the vector A first, and this is my vector B, and the according to law, two vectors which are to be added are taken as two adjacent sides of a parallelogram, then the resultant would be the diagonal of the parallelogram starting from the same point. So this diagonal R is basically vector A plus vector B. This is the law. Now how do we prove it? We actually can prove, this is the law actually, we don't have to prove anything in the law. This is the law that this will be the resultant. That means whatever net effect A and B will produce, the same effect will be produced by the resultant, which is the diagonal of the parallelogram, right? What we can do is we can find or we can derive an expression for the value of resultant, which is R, which will come out to be same again, because in this also you will do the same construction here, and this angle is theta, whereas this whole angle was theta. So this is theta, these two angles are corresponding angles, this is also theta. So these two sides, which is perpendicular, you will do the same, exactly same derivation which we have just done in triangle law, and we will get the same result, which is under root a square plus b square plus 2ab cos of theta. One very important thing, actually two important things, I'll go one by one. First of all, just go back to the video and see how I was adding up two vectors which were in same direction, basically two force of 10 newtons and 5 newtons. I was making them act on a box, and the resultant was 15 newtons if they were acting in same direction, and the resultant was 5 newtons when they were acting in opposite directions, right? Now what will happen if I apply the formula in that case? In first case, the box was acted upon by forces in same direction, right? 5 newtons and 10 newton. So what exactly is the angle between vector A and B here? They are in same direction, so theta is 0 degree. So if I apply the formula of resultant, a square plus b square 10 square plus 5 square plus 2 10 5 cos of 0 degree. What is cos 0? Cos 0 is 1, so this is removed. This whole thing is in the form of a square plus b square plus 2ab, which is a plus b whole square formula, which is 15 square under root, so basically 15. So even if you will apply the formula, you will get the same result. So what we did there was in accordance with the resultant formula. Same ways, if second force was acting opposite to it, 5 newtons, so the angle right now is 180 degrees, and here cos 180 is minus 1. So cos 180 is minus 1, this whole thing becomes 10 minus 5 whole square, which is 5 whole square, which is 5. So formula is very well valid. Second important thing was, in triangle law of vector addition and in parallelogram law of vector addition, we got the same answer, which is a square plus b square plus 2ab cos theta. But here we have one more thing. Suppose this angle is phi. So I want the angle, this angle which resultant makes with triangle or the vector A. So I am talking about this angle, right? So tan phi would be this upon this, right? This is tan phi. I have to name them. Let us say P, Q, R. I won't take R. P, Q, S, N. Okay. I have changed the name of the vertex, so hardly matters. Tan phi would be Qn upon Pn. Qn upon Pn. This is clear? Now, Qn upon, instead of Pn, I can write it Ps plus Sn. Ps plus Sn. This is also right. Now, I want to write these things in the form of A and B. So, I will be using this triangle first of all. If this vector is B, then this vector is also B. Equal vectors are what? Two vectors in same magnitude and in same direction are equal vectors. So, this is also vector B. So, if I have to write what? Qn in terms of SQ, which is B, so I can use which identity? Sine cos tan. I will be using perpendicular and hypotenuse. That means I will be using sine identity, which is sine theta is what? Qn over Qs, right? Qs is nothing but B. So Qn is Qs sine theta. I am not writing Qs sine theta, I will be writing straight away B sine theta, right? So numerator is B sine theta upon Ps. Ps is the magnitude of vector A, which is A plus Sn. Like this only you can find that cos theta is Sn upon Qs. Therefore Sn is equal to Qs is what? B sine, B cos of theta, sorry. So A plus B cos of theta. So see, can you find any pattern here? Just a second, you can write it down and I'll show you the pattern and how to memorize this formula. I just derived the formula for tan phi. Phi is the angle which resultant makes with vector A, right? So when resultant makes some angle with any vector, the answer is in such a form. This is how you can remember the formula. Tan phi is, first of all, write sine theta upon cos theta. This is what tan is usually, right? Now, whichever side the angle is to be found out, for example, you want to find the angle with the vector A. So, A will be in the denominator, the other vector B will be both sides. This is how you can memorize the formula. So, this is the relation, this is the new thing in parallelogram law of vector addition.